who should decide the future of Africa. For generations, many of the most important technologies used across the continent were designed, financed, and controlled somewhere else. That reality shaped not only African economies, but also African security. Today, Burkina Faso is trying to challenge that pattern by asking a different question. What happens when young Africans are trained not only to use technology, but to create it for the survival of their own nations? That question has become especially urgent in a country where roads can hide deadly threats beneath the soil. Burkina Faso has faced years of attacks involving improvised explosive devices and homemade mines. These weapons do not only target soldiers. They can strike supply convoys, block access to isolated communities, interrupt humanitarian assistance, and make ordinary travel dangerous for civilians. This is why a locally developed mine detection robot has attracted so much attention. It is not simply a machine displayed at a science forum. It represents an attempt to place technology between a human life and an explosion. The robot was presented as a remotely controlled system designed to move ahead of soldiers and vehicles. Instead of forcing a person to approach a suspicious area with a handheld detector, an operator can guide the machine from a safer distance. The robot can search the ground, identify warning signs, mark the suspected location, and send an alert back to the operator. Its importance begins with a simple principle. A machine can be repaired or replaced. A lost life cannot. This is also where the political vision associated with President Ibrahim Traore enters the story. He did not invent the robot, and there is no verified evidence that he personally directed its design, but his government has repeatedly placed scientific research, digital sovereignty, technical training, and local innovation at the center of national development. The message behind those policies is clear. Burkina Faso does not want its young people to remain permanent consumers of technologies created elsewhere. It wants them to become builders, engineers, programmers, and problem solvers. That is the meaning of a technology warrior. It is not a young person being pushed toward war. It is a young person being prepared to defend society with knowledge. A software developer can protect national data. An agricultural engineer can protect food production. A medical researcher can protect public health. And a robotics engineer can design a machine that may one day protect soldiers from hidden explosives. Before we continue, subscribe to the channel if you believe African innovation deserves serious attention, careful analysis, and a voice beyond the usual stereotypes. The mine threat in Burkina Faso is not an abstract issue. Explosive devices can slow military operations, disrupt supply routes, and trap communities behind unsafe roads. In such an environment, detection technology becomes more than equipment. It becomes part of national resilience. The robot, therefore, carries two forms of value. The first is practical. It may help create distance between soldiers and danger. The second is symbolic. It tells a generation of young Burkinabe that the problems surrounding them are not only burdens to endure. They can also become challenges to study, design around, and solve. And that may be the most important beginning of all. The prototype itself deserves attention, but a more important question lies beneath its metal frame. Why would a country with limited financial resources invest its own talent in building a mine detection robot instead of relying entirely on imported equipment? The answer begins with how the machine works. Unlike a traditional handheld metal detector, this prototype combines several technologies into one platform. According to its developers, it uses metal sensors, gas sensors, and artificial intelligence to improve the probability of detecting explosive devices. Rather than depending on a single signal, the system compares information from different sensors before alerting the operator. This approach is designed to improve reliability, especially because many improvised explosive devices are difficult to identify using only conventional metal detectors. The robot is remotely controlled, allowing an operator to remain about 100 meters away while guiding it toward a suspicious area. It also features an extendable detection arm that reaches approximately 3 to 4 meters in front of the machine, enabling it to scan the ground before the main body advances. When the system identifies a possible threat, it can mark the location with paint, trigger an audible alarm, and send a notification to the control unit. These functions help soldiers identify dangerous zones while maintaining a safer distance from potential explosions. The developers also explained that the robot can support 2 different missions. If specialists need to examine an explosive device, the robot simply marks the location for later inspection. If the priority is to reopen the road quickly, the design allows the machine to carry a small explosive charge that can be placed on the target before the robot withdraws to a safe position. This gives military teams greater flexibility depending on operational needs. Even more interesting is the team's long-term vision. They hope to integrate the technology into military pickup trucks, so vehicles at the front of convoys can scan roads continuously. They have also discussed adapting similar capabilities for drones, allowing dangerous areas to be inspected from the air before ground forces move forward. At this stage, however, it is important to remain realistic. There is no verified public evidence that this prototype has entered large-scale military service or completed extensive battlefield testing. It should therefore be viewed as a promising engineering prototype rather than a fully operational defense system. Yet, this does not reduce its importance. Every major technological achievement begins with an early prototype that must be tested, improved, and refined. The true significance of this robot is not that it has already transformed military operations. It is that young Burkinabe engineers chose to confront one of their country's most urgent security challenges with locally developed technology. That decision alone represents a powerful shift in mindset, proving that innovation begins when people stop asking who will solve their problems and start building solutions themselves. The mine detection robot tells only part of the story. If we focus only on its sensors, its remote controls, or its engineering features, we miss the larger transformation taking place inside Burkina Faso. The real ambition is not simply to produce one successful machine. The greater ambition is to create a generation capable of solving national problems through science, engineering, and innovation. This is where President Ibrahim Traore's broader vision becomes important. While there is no evidence that he personally designed or directed the development of this robot, his administration has consistently emphasized scientific research, digital transformation, technical education, and technological sovereignty as key pillars of Burkina Faso's future. In official speeches, he has argued that Africa cannot secure lasting development if it depends entirely on technologies created elsewhere. Instead, countries must gradually build the knowledge, skills, and institutions needed to develop solutions for their own realities. From that perspective, the mine detection robot is more than an engineering prototype. It represents the type of innovation that national policies are trying to encourage. Rather than waiting for foreign companies to solve every challenge, young Burkinabe engineers are beginning to ask a different question. What can we build ourselves? That shift in thinking may become far more valuable than any single invention. The same philosophy extends well beyond national defense. A student who learns robotics today could one day develop agricultural machines that help farmers increase food production. A software engineer could design secure digital systems that protect government data. A biomedical researcher could create affordable medical equipment for local hospitals. A renewable energy specialist could improve electricity access in remote communities. In every case, technology becomes a tool for strengthening national resilience rather than simply following global trends. This is why the idea of a technology warrior deserves careful explanation. It does not describe someone carrying weapons onto a battlefield. Instead, it describes citizens who use knowledge, discipline, creativity, and scientific thinking to defend their country's future. Their weapons are algorithms, engineering designs, laboratory research, and practical innovation. Their battlefield is the classroom, the university, the research center, the workshop, and the technology laboratory. To support this vision, Burkina Faso has expanded science forums, digital transformation initiatives, robotics competitions, and programs designed to encourage innovation among students and young researchers. These efforts aim to connect universities, inventors, entrepreneurs, and public institutions so that promising ideas have a better chance of becoming practical solutions instead of remaining classroom projects. At the same time, building a true technology ecosystem requires patience. One successful prototype does not automatically create an advanced technology industry. Long-term progress depends on sustained investment, modern laboratories, qualified teachers, industrial partnerships, intellectual property protection, research funding, and opportunities for engineers to test, improve, and eventually manufacture their inventions. Every country that became a technological leader followed this difficult path over many years. Perhaps that is the most important lesson hidden behind this robot. Its greatest achievement is not that it has already transformed military operations. Its greatest achievement is that it symbolizes a new mindset. More young people are beginning to believe they can become creators instead of permanent consumers of technology. If that belief continues to grow, the robot may one day be remembered not as the destination, but as one of the first visible steps in Burkina Faso's journey toward technological self-reliance. If the mine detection robot represents the first visible step, the next question becomes even more important. Can one invention truly change the future of a nation? The honest answer is no. A single prototype, no matter how promising, cannot transform an economy or secure a country's technological independence. What creates lasting change is an innovation ecosystem that allows one successful idea to inspire. Burkina Faso appears to understand this challenge. In recent years, the country has organized national science and innovation forums, expanded digital transformation initiatives, supported robotics competitions, and encouraged universities to work more closely with researchers and public institutions. These efforts are designed to create an environment where young innovators can develop practical solutions instead of allowing creative ideas to disappear after graduation. One encouraging example is the growing participation of Burkinabe students in robotics competitions. Young participants are learning how to design, assemble, and program robots while working together to solve real engineering problems. These competitions are not simply about winning medals. They introduce students to teamwork, critical thinking, and problem-solving skills that can later be applied to industries such as agriculture, healthcare, transportation, energy, and national security. This approach reflects an important lesson observed in many successful technology nations. Innovation rarely begins with large factories. It usually starts inside classrooms, research laboratories, engineering workshops, and universities where students are encouraged to experiment without fearing failure. Every successful prototype becomes both a technical achievement and a learning experience for the next generation of inventors. The mine detection robot demonstrates exactly how this process can work. A small group of engineers identified a serious national security challenge and attempted to solve it using locally developed technology. Whether or not this particular prototype eventually enters military service, the experience gained by its designers cannot be taken away. They have already developed new engineering skills, learned how to integrate multiple technologies, and demonstrated that complex problems can be approached with local expertise. For this reason, the robot should not be viewed as an isolated invention. It is part of a much broader effort to strengthen scientific capacity across the country. A sustainable technology ecosystem requires universities that encourage research, businesses willing to invest in innovation, government institutions prepared to support promising projects, and private industries capable of transforming prototypes into reliable products. Without those connections, even brilliant ideas may never move beyond the laboratory. Building such an ecosystem also requires patience. Countries recognized today as global leaders in technology spend decades investing in education, research, manufacturing, and industrial cooperation. Burkina Faso is still at the beginning of that journey. The road ahead will include technical setbacks, financial limitations, and difficult decisions. Those obstacles are normal for every nation attempting to strengthen its technological capabilities. The most valuable achievement may therefore be the confidence that this movement creates. When young people see engineers from their own country designing sophisticated machines, they begin to believe that scientific innovation is not reserved for wealthy nations alone. That confidence encourages more students to study engineering, robotics, artificial intelligence, and computer science, creating a cycle in which every new inventor inspires another. In the end, technology ecosystems are not built by one robot. They are built by thousands of curious young minds who decide that the future of their country is a problem worth solving together. The progress made inside Burkina Faso has attracted attention far beyond its borders. Supporters see the mine detection robot as evidence that African countries can develop practical technologies for their own security challenges. Others remain more cautious, questioning whether a prototype can deliver meaningful results without extensive testing, funding, and long-term industrial support. Both perspectives deserve careful consideration because they reveal an important debate about the future of technological development in Africa. Some observers in Western media and research circles argue that projects like this should be evaluated carefully before they are presented as major breakthroughs. They point out that advanced military technologies require years of testing under real operational conditions before their effectiveness can be confirmed. This is a reasonable position. Engineering credibility depends on evidence, not enthusiasm alone. There are also concerns about the growing use of artificial intelligence and robotics in military environments. Around the world, experts continue to debate issues such as safety, accountability, and human control over autonomous systems. These discussions are not unique to Burkina Faso. They apply equally to countries with far larger defense industries, including the United States, France, and many other technologically advanced nations. However, caution should not be confused with dismissal. The fact that a prototype has not yet entered large-scale service does not mean it lacks value. Every successful technological industry began with experimental designs that required years of refinement. Judging an invention only by its first version ignores the long process through which innovation normally develops. The mine detection robot should therefore be viewed as an early engineering effort rather than a finished product. Its greatest strength is not that it has already solved every technical challenge. Its importance lies in proving that local engineers are willing to confront complex national security problems with their own knowledge and creativity. That change in mindset may ultimately have greater long-term value than the prototype itself. Another challenge comes from misinformation. Social media often amplifies exaggerated claims, unverified success stories, or even artificial intelligence-generated content presented as authentic. Such material can create unrealistic expectations and weaken public trust when the facts fail to match the headlines. For that reason, genuine achievements should always be separated from unsupported claims. Real innovation does not need exaggeration. It becomes convincing through transparent testing, measurable results, and continuous improvement. The experience of Burkina Faso also offers valuable lessons for other African countries. The first lesson is to invest in people before investing in equipment. Machines can be purchased, but engineers, scientists, and researchers must be educated over many years. The second lesson is to solve real national problems instead of copying technologies designed for different environments. Innovation becomes meaningful when it responds to local needs. The third lesson is to build complete ecosystems that connect schools, universities, research centers, businesses, and government institutions. Finally, technological self-reliance should not mean isolation. International cooperation, knowledge exchange, and responsible partnerships remain essential while countries gradually strengthen their own capabilities. In the end, the debate surrounding this robot is about much more than one invention. It is about whether African nations believe they can move from importing solutions to creating them. That question will shape the continent's technological future far more than any single machine ever could. The discussion surrounding Burkina Faso's mine detection robot ultimately leads to a much larger question. What kind of future can African countries build if they continue investing in their own knowledge instead of depending almost entirely on imported solutions? No single invention can answer that question. Yet, every successful innovation has the potential to inspire thousands of others, especially when it changes the way young people think about their own abilities. The story of this robot is not simply about engineering, it is about confidence. For decades, many African students grew up believing that advanced technology would always arrive from somewhere else. Today, projects like this suggest a different possibility. A young engineer studying in Ouagadougou may one day design equipment that protects soldiers. Another may create software that secures government data. Someone else may develop medical devices, agricultural machinery, or renewable energy systems that improve everyday life across the continent. Every innovation begins with the belief that local problems deserve local solutions. This lesson extends far beyond Burkina Faso. Across Africa, countries face different challenges, but they often share the same opportunity. Investing in education, research, engineering, and scientific institutions creates knowledge that remains valuable for generations. Imported equipment can solve immediate problems, but locally developed expertise creates lasting capacity. Nations that train engineers, researchers, and innovators are investing in resources that cannot easily be taken away. At the same time, technological independence should never be confused with isolation. Modern innovation depends on international cooperation, scientific exchange, responsible partnerships, and access to global knowledge. Even the world's leading technology, nations collaborate across borders while continuing to strengthen their own research capabilities. The goal is not to reject cooperation, but to participate as capable partners rather than permanent consumers. The debate surrounding President Ibrahim Traore reflects this broader reality. Supporters view his emphasis on scientific research, digital transformation, and technological sovereignty as an opportunity to encourage a new generation of innovators. Critics question whether these ambitions can overcome financial constraints, institutional challenges, and the practical difficulties of building a competitive technology sector. Both perspectives highlight an important truth. Lasting progress cannot be measured by speeches alone. It must be measured by schools that produce skilled graduates, laboratories that generate useful research, companies that manufacture reliable products, and inventions that improve people's lives. Perhaps that is why the mine detection robot deserves attention. It is neither a miracle nor a symbol of instant technological success. It is an early chapter in a much longer story. Every advanced technology industry began with individuals willing to test ideas, accept failure, improve their designs, and keep moving forward despite limited resources. Whether Burkina Faso ultimately achieves its ambitions will depend on many factors, including education, investment, industrial development, and continued support for scientific research. But one lesson is already clear. A country begins changing its future the moment its young people believe they can become creators instead of spectators. As African news continues to follow technological developments across the continent, the experiences of Burkina Faso, Ibrahim Traore, Mali, Niger, Assimi Goïta, Abdurrahmane Chiani, and the wider Sahel region will remain important to understanding how innovation may shape the future of West Africa. Whatever path these nations choose, the African Union, regional cooperation, and constructive engagement with partners, including France, will continue to influence that journey. If this story has given you a new perspective on Africa's technological future, subscribe to the channel, share this video, and join us as we continue exploring the ideas that are helping shape tomorrow's Africa. As we reach the end of this story, it becomes clear that the mine detection robot is about far more than technology. It represents a new way of thinking about Africa's future. Instead of asking when outside solutions will arrive, more young Africans are beginning to ask what they can build with their own knowledge, determination, and creativity. That shift in mindset may become the most valuable achievement of all. Burkina Faso still faces enormous challenges. Building a strong technology sector requires investment, modern education, advanced laboratories, industrial partnerships, and years of continuous research. Success cannot be guaranteed, and no single invention can transform a nation overnight. Yet, history repeatedly shows that every major technological power started with people willing to experiment, accept failure, improve their ideas, and continue moving forward despite limited resources. The mine detection robot symbolizes that first step. Whether it eventually becomes a widely deployed military system or simply serves as a foundation for future innovations, it has already demonstrated something important. It has shown that young Burkinabe engineers are prepared to confront complex national problems with locally developed solutions. More importantly, it sends a message to students across Africa that scientific knowledge is not only a path toward personal success, but also a way to strengthen national security, economic development, and social progress. President Ibrahim Traore has repeatedly emphasized the importance of scientific research, technical education, digital transformation, and technological sovereignty. The long-term success of those ambitions will ultimately depend not on speeches, but on whether future generations continue building practical solutions that improve people's lives. The real measure of progress will be seen in stronger universities, better research institutions, successful technology companies, and innovations that serve ordinary citizens as well as national development. For other African nations, the lesson is equally significant. Investing in young engineers, researchers, programmers, and innovators may become one of the most important investments any country can make. Machines may eventually become outdated, but knowledge continues to grow from one generation to the next. That is how lasting technological independence is built. As Africa News continues to follow developments across the continent, the experiences of Burkina Faso, Ibrahim Traore, Mali, Niger, Assimi Goïta, Abdulrahmane Chiani, and the wider Sahel region will remain important stories for everyone interested in the future of West Africa. The role of the African Union, cooperation among neighboring countries, and constructive engagement with international partners, including France, will continue shaping this evolving journey. Perhaps the greatest question is no longer whether Africa can create advanced technology. The real question is, how many young minds will choose to become the next generation of innovators, capable of transforming their communities through science and determination? If you believe Africa's future will be shaped not only by politics, but also by education, innovation, and courageous young creators, subscribe to the channel, share this video with others, and join us for more stories exploring the ideas that are helping build tomorrow's Africa. We sincerely appreciate your time and support. Every video on this channel is carefully researched, thoughtfully written, and meticulously edited by our dedicated team. We don't rely on automated production or shortcuts to create our content. Every story, every visual, and every detail is crafted with genuine care, passion, and a commitment to bringing you meaningful, high-quality videos.